Hello guys, and welcome to another video about game development. And in this one we're going to talk about game programming and various game engines in that manner. There are a lot of game engines out there that can make games, and many of them are pretty good. And so we're going to talk about how, if you're a beginner, how should you approach it, and what's the different options you have to start doing your starting your game journey. And our whole department just finished a game development book, and I suddenly finally got a chance to really talk about it because we were really busy before. Anyway, so yeah, let's talk about game development. So there's a lot of comparisons between different game engines, and there's a lot like competitions in that matter too, which is a good thing because when there's competition, there is development and there is pressure, right, on the developers. So which pushes them to do better and to deliver the best quality they can. So we'll be benefiting from that. So I think it's really healthy to talk about it. So I want to talk about few engines today, and specifically focusing on the programming part. There are other topics about graphics. A lot of times they're comparing graphics, but in my opinion, I think graphics is drastically based on the artist and the workflow, and not necessarily has to be determined by the engine. I think more than 90% of the final result is going to be determined by the user, not the engine in that case. But nonetheless, I think we can all agree that when it comes to graphics, Unreal Engine is the easiest to achieve a very good result. So you don't have to really do anything. Basically, just bring your assets, connect the textures, drag in a few lights, and hit build, and the result is guaranteed to be good. If you control it artistically, of course. Anyway, so. But we're going to focus on programming today, and talk about the pros and cons of different programming languages to use, and then compare them by doing some simple examples in this case. So when it comes to programming for games, there are, for every game engine, there could be like one or two programming language that's supported. And when it comes to actually making the engine, there's no debate here. Like most of the game engines are developed in C++, just because you need every bit of a performance out of your hardware. So C++ is the best programming language for that, and it's not like we don't want to use things like C# to create like a game engine or any other fast software in that manner, like Maya or DS Max. It's not because we don't want it to, but we just have to use C++ because it's the only answer to high performance hardware in that case. But it doesn't mean we have to use C++ for making the game or using the engine. So many engines implement their scripting language or adapt other programming language as their scripting language to make a game, and that's not the same language that makes the game. For example, in Unreal Engine, the language can be C++ if you wanted to. It can also be a visual scripting language called Blueprint, which is basically you drag in nodes and create nodes, and you just connect them with lens, and you're programming already. Other engines like Unity uses C#, general purpose languages, and there are other game engines that uses things like Java, Lua, and Python, some iterations or similar things to Python in that manner. So the scripting language can be varying a whole lot, and it's drastically different from game engine to game engine. Okay, with that being said, let's talk about like how to make something in a game engine and compare that or do that in different game engines, so you can get a taste of how it feels like to program in those various packages. Okay, so here we can start with Unreal Engine's Blueprint, which should be the easiest in that case, because it doesn't really require you to write anything, right? It's less scary in that manner. So I'm gonna go ahead and go to the content browser in Unreal and just create a new blueprint class. I'm gonna call this actor. Right, I'm gonna name this guy looker. Right, what we're gonna do is very simple. We're gonna make the looker to look at or facing the player in this case. Okay, so I'm gonna go give it a new variable called look target, or maybe just call it target. Yeah, that's easier. And then we're gonna change that to a actor type. Okay, and actor is going to be anything you can place in the scene. It's basically the base class of everything you can see in this environment. Okay, so after that, I'm going to go to the event graph. And then here you can see two very major functions. This one is not important, so let me move it away. All right. So you have begin play and tick. Begin play is called whenever this thing becomes active in the scene, either when the game starts or when it's spawned in the level, right? And this is getting called. And tick is called every tick when this thing exists, or every time this game update, or every frame you see on the screen. This one is called. Okay. So we're gonna use that to force this guy to look at the target. Okay. And by the way, this guy doesn't have any visuals. So I'm gonna go to the component and we'll give it a static mesh component. Or we can just choose a cube. It's a static mesh with a cube already. Alright, so I'm gonna scale it on the X direction. That's the front direction in Unreal Engine. This may not be the same in other engines, but you can quickly determine that by grabbing a camera in the game engine. And then you can see the camera is facing the X axis, so you know that the front axis is defined as X axis. Okay, I'm gonna make it longer so it's easier to see where it's facing. Alright, let's do the job here. I'm gonna go grab the target and say get actor location, where it is, right? And I also need to get actor location here for this guy, right? Oh, not this, get actor location, right? Which is target itself. This one's target is the target, right? And we can then drag out from here and then say find look at location, rotation, sorry. And then this is going to give us the rotation needed to make this actor to look at this actor, which is this guy, right? To look at target. And then we can just say set actor rotation, and that goes to there, right? You can see this is node-based scripting, right? What it does is set the rotation of this actor we're working on with this new rotation. New rotation is calculated by this find look rotation node, which takes the location of the actor and location of the target and find out what rotation is needed for the start location to look at the target location, and that's going to be the new location rotation for the for this object. I'm going to close that and then drag this guy over here. And then I can go here and, oh, actually there's one more thing. You have to make it public by clicking on this little eye here and compile and save that. Now you have a target. You can pick a target here in the scene by clicking on the add drop and just clicking there. Alright, now play the game. You can see now this cube is always looking at the player because we tell it to, right? This is a very quick view of how programming would be like in Unreal Engine for beginners, right? It's basically creating nodes, creating variables, connecting nodes, and to do the functionality. Every node has a functionality to do, like this is a set actor rotation. You can set actor location, right? Maybe we can make this guy's always above the player. We can say get actor location, and then we can do a add vector plus vector, and we can go up. Z is the up axis. Right, we can make it 500 units higher, and that goes to the new location here. Right, comparison, I've saved that. Now you can see it's always above the the player. In this case, we can F8 to jump out from the character. You can see now it's banned location wise. Right, I don't think you can even move it away. Anyway, all right, cool. So that's basically how programming would look like, right, in Blueprint. And let's compare that with Unity. In this case, I'm gonna go to the Unity, right? And we have an empty scene, but we can quickly do very similar things by going a sphere maybe, and then a cube. Right, now again, if you don't know where the front direction is, you can grab a camera. You can see this camera is looking at there, right, which is the z-axis, so you know that z is the front. I'm gonna scale it on the z direction and move it out, and this is the sphere, right? Now to achieve the same functionality, we have to attach a script to this guy, right? So I'm gonna go to the inspector, add component, and then new script. Oh, wait, I'm searching rigid. So yeah, just go script, and then let's just type in script, I guess. New script, and then I'm gonna call this guy look at target, not target. I guess you cannot really change the name after you do this because it's in there now. Anyway, yeah, let's just double click to open it. You can see now we're opening Visual Studio, and we have very similar things. Even it's text based, you can see the two things I was talking about in Unreal, right? Start and update. And there's even comment here which says this is called before the first frame update. First frame it updates, right? It's not the game updates, it's the object it updates. And then update is called once per frame on the update, right? So that's basically the begin play and tick equivalent. If you go here, right? This is the tick we're calling here. Let me dock it in there so we can shrink it a little bit. Whoops. Yeah. So you can see start, update, begin play, tick. That's the one-to-one match. Right, so let's go ahead and implement the same thing here. We need a target again, so we're gonna do public, and then game object. I believe that's it, and then target. Right, and this is how we name that variable. And this is basically all you have to do this is the equivalent of basically doing this thing by clicking on the add new variable here, right? And then in the update, we can just say transform dot look at, which is pretty easy here, and then we can say target dot transform. Okay, and then we save this and then go back to Unity. It's gonna take a while to compile. Oh, I must have typed something wrong. Transform, not from. Save that. Okay, make it wait for it to compile, right? And then we can grab the cube. You can see this script is in here now, and the target is exposed here just like in Unreal, and then we can just we can drag the sphere to there, right? All right, now we can play the game. Okay, I'll go to the scene maybe and grab the sphere and just drag it. You can see now it's following the sphere, the same thing, right? And you can already see the difference between scripting language and visual scripting, right? The difference here is the scripting language is basically written in text, and sometimes it can be pretty compact compared to node-based. By comparing, you can see, of course, they are slightly different when it comes to what we're doing here. And let me get rid of that. So this is the code in Blueprint that does the same thing compared to the code in Visual Studio. You can see this feels bulkier, right, for sure, but also it feels more visually pleasing compared to that, right? And I think this is personal preference, but for beginners I would recommend you to learn a scripting language first, like learn C# here instead of Blueprint, because if you're not careful, you probably will be learning something really bad. Like there's many tutorials on YouTube or somewhere, like you know, and there's bad practices because easier language, right? They encourage bad practice sometimes. So and also like the way the programming works will be easier to grasp if you learn a scripting language like this. That's the comparison here, right? most of the game engines have very similar like approach here. Let's take a look at another game engine, which is Godot game engine. Okay, so this is Godot game engine. Oh, it's another game engine. Basically, this one, the difference here is this one is pretty lightweight. It's like 46 megabit. That's how big it is, and then it's totally open source and free. I have something set up here because there's no preset, but I can play the game. You can see this is basically like a touch screen kind of like a game, and there's some information here you can click and can play videos, but that's done outside of the game engine. I have some other things. So anyway, so let's implement the same thing here. Let's create something over here and make it looking at us. When we move away, we should see it looking at us. The same thing, right? So clear all that warning here. I'm gonna go to the this is basically the content browser, or the for all the game engine, you can see very similar layout. Even like in Unity, you have this project folder which has all the assets. In Unreal, you have content browser which has all the asset. Have a what outliner or a hierarchy. That's the same thing here. Viewport, details panel, inspector. Right, there's a 1-to-1 match in this case on the structure of these engines. Same goes for Godot. In this case, you can see the hierarchy or outliner, which is seen here. The file system, which is the project or content browser. Inspector is details panel or inspector in Unity. Right, this is the console, and that's the viewport. So we can see there's basically 1-to-1 matches. It's basically the same thing, almost like person grow in different ways in this case, but they're all humans. And I'm gonna go to the scripts and then add a let's do that with just something we can just add. So I'm gonna go add a spatial node, which is the basic base node that can be added in the scene, and then we can name this guy locker. Right, I'm gonna drag this guy up. Okay. All right, and again, if you want to see where things where the front is, you can go to the, I think I have the player here, right? Player, and then camera. Okay, and you can see it's facing that way, so that's going to be the negative direction of the z-axis. Right, so we can just work on the z-axis in this case. So I'm going to grab that locker. Oh, we don't have anything visual yet. We can Control A to add new component. I'm going to search for mesh component. Mesh instance should be fun. And then we can go to the mesh and then look for a box or cube. And we can scale it on the z-axis. Right. Okay. Now we can attach a script to it. Let's go to script and then go to empty. We can create a new script and call this guy look at target. That's the same thing. And then we're gonna go create. Oh, you know what? We're attaching it to the wrong thing. That's mesh distance. We should do that on the locker. So I'm gonna go here and fix that. I'm gonna go here and clear that. Back to the locker script. Let's delete that. Look at target because it's a different type. I'm gonna remove that. I'm gonna grab the locker here. Oh, go to the mesh instance, and then transform zero out its translation. I'm gonna go to the locker. Yeah. Okay. So go to the locker. I'm gonna go to the empty one and create a new script and look at target and create. Okay. Now this is gonna be based on spatial. Again, it's gonna be the same as the actor class we created earlier in Unreal Engine, right? Unity is more component based in that case, so it can be anything, I think. All right, so now with this, you can see ready function. Let's do some comparing here. We have ready function here, and I'm back here to C# with Unity. You can see start ready. right? You can see the comment here, called when the node enters the scene tree for first time, right? The same thing. And there's another one commented out here is the process with delta. This is called every frame, right? So there is again a 1-to-1 match in this case. So this is when I think we can have a conclusion that there's really not that much of a difference between game engines on a very fundamental level. As sometimes they could even share the same modules, like rendering module or networking kind of thing. That could be the same thing underneath even. All right, so let's just do the same thing here just for the sake of it. Right? I'm gonna say export, right? And it's gonna be a variable called target, right? And then equals, oh, that actually has to be belongs to the type of node pass, right? Okay. All right, and then here in the process, which is the update, right? We need to write our code here. I don't need to do that. I just need to grab this guy and maybe control K. Yeah, that's how you get rid of that. And then we can say var look target. I think we can do that one with one line. So we can say look at. Right, we don't even have to say transform look at. Just say look at. Right, and then we can say get node. Okay, and then target. Okay, that's the target here. We'll get a node from there. Right, and then translation. Translation. Okay, that should be it. Get node translation to figure out. Oh, there's one more argument here. Yeah, it's a little different, as you can see. It needs to know an up vector, which is basically a vector 3. So vector 3, and then up vector here is z actually y-axis, I think. Right. So let me just make it bigger. You can see the full code is basically also like look at. Then we get that node, we ask for its translation, and then we have to specify an up vector, which makes sense, but this one doesn't have that. Maybe it does have that. Let's see. Maybe it has a default value, or I'm not sure. But yeah, so you can see look at even the same name for the function, which is a slightly different way of typing things down. Like this is using a underscore here, while this one is using uppercase to differentiate, right? Okay, I'm gonna go ahead and save this, clear the log. Yeah, now back here to the 3D scene, we can grab the looker, and then we can see we have this target here, right? We can click on the assign, and we can grab the player, hit OK, and then we can go ahead and play the game. Okay, yeah, it's over there. If I move over here, you can see it's looking at me. Right, so as you can see, well, is there really that much of a difference? I don't think there is on the basic level. You just have to know your way around and figure out or find the function you want to look for, and just do your scripting from there. Of course, it takes a while to really remember a bunch of things, like how to get this thing be in here. Like it has to be cannot control Z, I guess. Has to be written in this way, right? You can get node by doing that. So it's gonna be taking some time to work on it, but you can also see like how similar they are when it comes to like structure. Okay, just another game engine to have some fun here. Another game engine called Play Canvas. Okay. This game engine has a ball here. We have is some very basic controls. If you play the game, it's gonna take a while to load, basically. Yeah, you can just use the arrow button to drag the ball around, basically. Right. So back here, again, right? Let's do the same thing. So I'm gonna go create a little cube model here, And then with the model selected, I'm gonna give it a box. Okay, and then let's see where it is. Okay, all right, and then let's also grab the camera and let's see. Probably need to go to the object mode, and let's see, it's also z-axis in this case. So I'm gonna go to the scale and just scale it, make it smaller, longer, right? Cool. And then we're gonna go to the add component. We're gonna add a script in here, right? And then I'll add a script. There's no script here we can use. Just create a new script. We can call this guy look at target. All right, now we can double click to open the script. All right, and then it's loading here. You can see this is using JavaScript. Okay, Java is kind of like a weird language to me. It's very capable and it's very popular. It's probably the most popular programming language out there. Probably ranked #1 now. It probably will be ranking #1 for a while. I don't feel like I like the paradigm it's proposing. Like functions and variables and objects, they're all the same thing, right? A function is an object. You can pass function into as an argument, almost like a lambda thing in C++, if you know some older languages. But you know, it's people were saying this is the cancer of programming language, because it does, anything can be anything. In this case, it's just so weird. But let's do it. Okay, so again, we need to specify the target, right? So I'm gonna say this object, which is, oh, did I name it loot target? Okay, so anyway, attributes dot add, and I want to add an attribute. Right, the attribute will be called, you guessed it, target. And then we need to specify the type. So type will be equals to an entity, right? All right, so this create a target here. If you go back here to the editor here, you can grab the model, and you can see we can parse it, I think. Okay, now you have a target. You can click on that, and we can choose the ball as the target, which is the one we're playing. Right, you can see now it's using that as the target. All right, now you can also see the two functions we're talking about, the initialize and the update. You can see the comment called per frame, called once per entity, right, when it started, and this is called every frame. So this is basically the equivalent of, again, the thing we're talking about, the begin play and the tick, the start and the update, right, and the ready and the process. They're just naming differently, but it's the same thing. Just like what I said before, those different game engines are like, they're all humans, but they grow differently, but they're all humans in that case. They can do things human can do. Anyway, so yeah, we're gonna update, we're gonna do the coding again, right? So I'm gonna say this dot entity, which is, you know, basically like what this is, and then we can call the same function called look at, right? And then we can say this dot target, which is the target, right? Dot get position in this case, and you know, look at that position, right? That it's that simple. Now here, back to the game engine, I'm gonna go ahead and play it again, and you wait for it to load, and now it's looking at me. When I'm moving away, you can see the cube is always looking at me. Alrighty, so as you can see, we compared 4 game engines. We look at their structure, and you see how similar they are, right? Their similarity is bigger than their differences, at least for beginners. When you look at it, you can see here hierarchy, asset, entity, which is the inspector equivalent, right? The console is somewhere else. What's funny about this is that this is running on a web page, right? This is totally online. And everything here is, this is a new page actually. So this is a OpenGL based game engine. So what if you want to do like web development in this case, then game engines like this will be making a lot of sense, because all those things, this is JavaScript, right? It's the backbone language for any web page, and you can hit F12 to pull up the console here. This is just the console of your web page, and you can go to the elements. You can see what's going on in here. If you of course you have to play the game to see that. Oh, I think I Control Z so that one is null now. Grab the ball here. Okay. I guess I have to restart the game. Right, because this is based on the web page, you can use the console to see what's going on, like what's going on to the whole image, what the code is doing right behind it. My screen's too small. Right, so there's a lot of things you can see here already. So it makes sense, right, to use this web-based engine if you are doing web development. The other engines like Unreal, Unity, or Godot, they don't really they don't really create code that's readable, and they're creating some assembly, and they're just very heavy in that manner, right? So it wouldn't be ideal in this case. And I have tried to develop something with Godot for web, and I encountered some issue with different devices for web page. Okay, so like this is one of the thing that's running on the web, right, from Godot exported for HTML5. But I had a problem with playing the video in there because the iOS is having video buffer issues. But this one you
Hello，
can
大家好，
see
这里是钱妮儿。
this one is playing the video using HTML5. It's totally bypassing the video system in the engine, and it's done by doing JavaScript. And I'm basically changing the HTML file with my own JavaScript to create video players for HTML5 in this case, and totally bypassing the video system of the game engine. So sometimes you have to do this, extend from the engine and do something else from there. All right, cool. So I guess one last thing I want to show you is sometimes game engines support multiple languages. Like for example, in Unreal Engine in this case, instead of doing it with Blueprint, I can also do it with C++. Let's take a look at this last one, which also proven to be the most difficult one to deal with. You'll see why people don't want to use C++ if it's possible, because it's a difficult language. But Unreal give you that option to use C++ because in their mind, I guess, professionalism and production quality is more important. So C++ is going to be the king when it comes to that. I'm going to go to the C++ folder and create a new C++ class. Again, an actor, and then next I'm going to call this guy Loker. Right, create class. Okay, you can see it's already a little bit slow because it has to really compile the code into the system. It's not like the other language we have experience, like in Unity, C#, right? This one. Oh, sorry. This one. Look, target CS. You can see. Oh, sorry. You don't have to see. But this one is using. This language is actually running on a virtual machine, right? It doesn't have to be compiled like to a machine code to run. There's a virtual machine underneath it to support it there, so it has a faster compiling time, and higher than that, this is, you don't even have to compile it just works. Whatever you change here, just it's instantly working, right? You don't have to do anything. The Godot script is very similar on that manner. Like you don't have that waiting time, right? In Unity, even you write something here, and you go back to the editor, you wait for it to compile, right? And in the other two engines, they don't. But here, this file is the new C++ class we created with Unreal Engine. But even that, you can see it's very similar. Start is, begin play, tick, and update. That's also a one-to-one match. You can see the comment here. This is called when the game starts or when this is spawned, and this is called every frame, right? Same thing here. So let's go ahead and do the same thing. I'm going to do a target is going to be of the type A actor pointer target. And now to make it available in the other engines, you just type in public or export in Godot, right? Export. But here you really have to do some sugarcoating here. You have to go above it and type in a U property, right? You can then say edit anywhere. No, edit anywhere. Blueprint read write. No. Category equals whatever. So this can be something you specify. I'm gonna call this game logic, maybe. I think I typed that anywhere wrong. Okay, so you have to add this code for it to be available in the editor here. Now, what does this code do? Well, it doesn't do anything in C++. If you take a look at what's going on with this macro, you can see it's defined as this thing, and it takes whatever argument you give it, and then there's no body, so it does nothing, right? This is all there is. So this is just some decorator you add on top of your variable, so that when Unreal processes it, it just read those texts and use it to determine if this should be appear in the game in the editor or something like that. But in C++, this equals to empty. Okay, all right. So yeah, we have the target here already. And you can see already there's some complications in this, right? You can see this is how long you have to write to create a variable compared to Unity C#. Just that. Okay, you can see the huge difference here. I think Unity is by far the only one I feel like it just use the natural programming of that language, right? In others, there's some sugar coding, like even here in Java, like add attributes. It doesn't have to be this way to add stuff. In Java is just var or this does something equals, right? It doesn't have to have attributes, I think, in that manner. And Godot is using its own script, so I'm not going to comment on that. This is GT script. This is just only existing in Godot, and then it has a export decorator to make it public, basically. But you can see the most complicated one here is in Unreal. You have to write that thing down in C++, right? Now here to the begin play and tick, you can also see, well, where is the body of the function? It just is. And where do I write down my code? The code is actually in another file called locker.cpp. You can see there are two files associated to this one thing instead of one file, right? The other three engines are just using one file. But in Unreal, there are two files, C++, basically having a header file, which is going to be the list of every variable and functions this class has, and then in the CPP file, that's actually the detailed implementation of various functions. Okay, you can see here we have begin play, we have tick again, but now they have this is called a namespace in front of them, because this is not in this file, so you have to really specify, or not in basically the curly bracket. You can see you have all the functions in the curly bracket here, right? So you don't have to specify this guy as the namespace, but here this is a different file, and because of that you have to really specify the namespace for it to work. You can see it's already getting more and more technical and complicated. And now we have the tick, we can write down the code in there, right? So we can say, first of all, we need to find the locate rotation in Unreal Engine. There's no locate function in there. So there's a function called find locate rotation, right? But this function, you cannot really just call it, because this is not a function of this object or this actor class, right? Actor class. So you really have to find where it is and include it. So you can Alt G and look for where it is. This is where it is, right? And it's in the file called Kismet Math Library. Right, you can click here on the very top. You can copy that directory. And here you can go to here, and you have to really include it to really use it. And also, it's because again, it's a different file, and you have to access it through the namespace. So this guy has to be in there, and the actual namespace defined there is having a U in front of it. That's just the naming convention. As you can see here, actor is started with the A, right? That's actor, and it added an A here. We name our class locker, but it's enforcing an A in front of it to indicate that this is a child class of actor. And here's U is going to be another naming convention for libraries, I think. So this is actually the whole thing you have to write down just to call the function. You have to include it, and then you have to have the namespace, and then you call it, right? And then you can pass in the variables. It takes a start and a target. Right, that's very similar. Start is going to be get actor location, and the target will be target dot get actor location. Right. Let me make it bigger, and this is going to be a variable we need to use. So I can say set actor rotation. Oh, I'm replacing that. That's not good. Set actor rotation to that. Okay, this is still one line of code, but you can see this one line is worth so much more lines in the other engine. You can compare Unreal C++ with Unity. You can see the length is right, that's the whole length here. That's that length. If I copy that code in here, so we can do a comparison, you can see 2 3 times more code or to write. But you can also see it doesn't really take a whole lot because of the auto completion and IntelliSense. You can get it up and running really quickly. I don't type in every little word here. Just find the hint really quickly and just use that. Right, so this is not a big pen in this case. It's still workable, and if this is getting too big, you can actually make it like that, so you have multiple lines of doing that. Okay. So that way you can see we're calling this function, and this function takes 2 arguments. Right, this guy is calling this guy which uses those 2. So that is, easier to see sometimes. Anyway, so yeah. Here, this one doesn't have any visual representation. We can add that later on, or we can add it in here. But let's just get rid of the C++ and do it later in the editor. So I'm gonna minimize that and go back here to Unreal Engine and click on the compile to compile it. And again, this is taking a little bit longer than Unity because it's C++. It has to be compiled into machine code. Okay, now it's done. You can see we have this locker added in here, right? And we can drag it into the viewport. Where is it? Drag it in. Did I draw? Yeah, I think I have a few ones in there already. Let me delete that and delete that. Let's drag one in again. Okay. And I hope I can move it. I guess there's no visual representation, so let me give it a cube here. Because oftentimes, if I'm doing it in C++, I need to create a blueprint child from it. But I think just for the simplicity, we just add a cube in there. Alright, now we can move it. Okay, it's in here, right, as a cube component. But also, it has a target. So we can just click on that and pick the target. Let's also scale it on the x-axis and play the game. You can see now it's also looking at us. Oh, okay. So yeah, that's basically, you can see we have explored 5 different programming languages to get it done. But other than just the syntax are different, the core are the same, basically calling this. And that's basically the truth in many process of making the game between different game engines. It's basically you're finding the right function for the right thing, and oftentimes they are similar. And so don't really worry about like, if I learn this engine, did I just, if I want to learn another engine, it's going to take equal amount of time. It's not that. Once you have learned one of them, the other one becomes easier, and the next one becomes even easier. And then it's just gonna get easier and easier, because your programming skill is not gonna be, back to zero when you started with a new programming language. The language is just syntax. The logic is what matters, and oftentimes they're completely transferable in that case. Okay, so we have talked about game programming, and as a beginner, my suggestion for you is definitely don't try to start with C++, because you can see that complexity already, right? But you can start with things like Blueprint if you just wanted to really don't want to code at all. But at some point, I would recommend you to pick up a scripting language like C#. I think is one of the most popular one in that case, right? This one. Java, definitely for web development. I think Java is going to be the king for web development. There's no other easy way around. And it's a cool language. It's a dynamic type language. Anything can be anything. Anything can be changed. A float can be an integer later on. Actually, there's no difference between float and integer. A float can be a string down the way somewhere in the middle. It's just, you can change anything to anything, which is pretty interesting. And then there's a lot other language like this Godot script. This is going to be something that's kind of like locking you a little bit more, because this language only exists in Godot, right? It's called Godot script, right? If you're using that, then using this language, you're pretty much locked to it. That doesn't mean, again, like you lost everything if you switch to a different engine. You just have to find the syntax, right? And this is by far, I think, the cleanest language between all these 3, because you can see that there's no semicolon, right? And then you can see the function and those things are just, there's no curly bracket. It's just more closer to a English. This is something very similar to Python programming language. It's gaining more popularity in the recent years. It's slow, but it's pretty darn good looking, right? Okay, cool. So yeah, that's about 1 hour of me rambling about game engines and different ways different game engines do the same thing, and how to prove to you that they are not that much different, but there's differences. It's up to you to choose one. My final thought here is going to be, don't listen to anyone who tell you which one you should use. Pick a one you feel comfortable with and you click with the most, and then you go from there. And having the demand that you are always capable of switching to other engines, because it is really not that much different. Alright, that's it for this video. Thanks for watching. See you next time.